In this video, we discuss the questions from 26 to 50 of 2016. Question number 26, 9 identical wires made up of same metal, each of diameter D and length L, are connected in parallel to form a single resistor. The resistance of this resistor is equal to the resistance of a single wire of the same length and diameter capital D. They are asking for an expression for capital D. And we take the equation for the resistance of a wire. It is given by rho L over A. Rho is resistivity, L length of the wire, A cross-sectional area of the wire. So we can write R equal rho L over A. And it has 9 parallel wires of same type. Then we have to find the combined resistance of that 9 wires in parallel. So we take the reciprocal. So now we think the combined resistance is R dash. So we can write 1 over R dash equal 1 over R. Before it was 1 over R plus 1 over R plus 1 over R 9 times. So that is 1 over R dash equal A over OL plus A over OL plus A over OL 9 times. So we can write 1 over R dash equal 9 times A over OL. So R is rho L over 9A. And we write the same equation for the other wire. Then we take the resistance is R double dash. R double dash equal rho L over A dash. A dash is the new cross-sectional area of the new wire. A dash. Then it says that this R dash and R double dash are equal. So we can write rho L over 9A equal rho L over A dash. So with that you get 9A equal A dash. A is the area, cross-sectional area. So we can find it by pi r squared. Here the diameter is given. So you can find R. R is diameter divided by 2 is R. So using the equation pi r squared for both wires, you can find capital D. It is equal to 3 simple D. Answer is 2. Question number 27. A structure consisting of straight wire sections is shown in the figure, and it is placed perpendicular to a magnetic field. And they are asking for the resultant force acting on this. Now, each wire carries current, and the direction of the magnetic field is towards your book, into the book. And to find the direction of the magnetic force, you can use the Fleming's left hand rule. So when you place your first 3 fingers perpendicular to each other, the thumb shows the direction of the force, second finger shows the direction of the magnetic field, and the middle finger the direction of the current. So in this case, you have to point your second finger into your book and middle finger to the direction of the current, and the thumb will show the direction of the force. So for AO, if you place your fingers accordingly, you can find the force is along the plane up, along the plane upward. For OB is also same, upwards. Then CO, then the force is perpendicular to CO um, to the left side, perpendicular to the CO and to the left. And OD, perpendicular to OD and to the right. The forces CO and OD are at an angle to the y-axis. So you have to find the component of these forces. So when you find the components, you can take two components in y direction and two in x direction. So that in the forces in x direction are opposite in direction, and they are being cancelled off, and finally only remain the upward forces. So the resultant force along the plane of the paper in the upward direction. The answer 1 is right. Answer 1 is right. Question 28. The waveform shown in figure is applied across the input terminals of the circuits P, Q, R, and S. They are asking if the potential drops across the diodes are negligible, which circuit gives the same output as the input. First, we take the P circuit, and you can see two diodes are connected to the terminal A, but in opposite directions. So the first diode will allow the positive part of the wave to pass through. And from the second diode, uh, it blocks the wave. So no output will be taken from the P circuit. Then Q, the first diode gives the positive side of the wave, and second diode also allows that to pass. So the output will not same as the input. In S, the A and B are connected through the diode, and B terminal is earthed. So the signal will pass through the diode, and it will be earthed. So this circuit is short circuited. So no output will be taken from S. Then two diodes are there connected in opposite directions. They are parallel. So the first half, that positive side, will be allowed to go through the first diode, and at the negative side, the second diode will allow uh, to pass through. So both positive side and negative sides will be passed through these two diodes, giving the same wave pattern as the output. So the answer is only R. Answer 3. Question 29. Two children are standing on a uniform rod which is balanced at its center of gravity O. Then they start moving simultaneously, but they maintain the horizontal equilibrium of the rod. And the three statements are given. They are asking which statement is true regarding the equilibrium of the rod. A, statement A. They should always move in opposite directions. Now, look at the system. Two children are apart, but their center of gravity is acting at the point O. Rod's center of gravity is also at O. That is why it is maintained at its equilibrium position. Now, if they move apart, they can maintain their center of gravity at the same place. If they move towards, then also they can maintain their center of gravity at the same point. So the first one is right. They should always move in opposite directions. B. They should move keeping their total linear momentum always equal to 0. At the beginning, their total linear momentum is 0. So at any time, they should maintain that their total linear momentum 0. Otherwise, there will be a force acting on it and it will affect the balance of the system. Then C, they should move so that the moment produced by one child about O is always equal and opposite to the moment produced by the other child about O. That is also true for the equilibrium, for the horizontal equilibrium of the system. The clockwise moment must be equal to the anti-clockwise moment about O. So C is also right. A, B, C all true. Answer 5. Question number 30. A uniform disc rolls without slipping along a horizontal surface and subsequently starts to climb up a ramp as shown in the figure. They are asking for the maximum height to which the center of mass of the disc climb. Now, when it's rolling on the horizontal surface, it has two kinetic energies. So, it rolls and it's move forward. So it has two kinetic energies. So one is rotational kinetic energy. The other one is the linear kinetic energy. This disc has two kinetic energies. Rotational kinetic energy is given by half I omega square. I is moment of inertia. Omega is angular velocity. So rotational kinetic energy is half I omega square. Then omega is not given here. So we know V equal R omega. So omega is V over R and I is given mr squared over 2. So we substitute this in half I omega squared. Then you get uh, rotational kinetic energy is mv squared over 4. Then while it's rotating, it moves horizontally along the surface. So linear kinetic energy is half mv squared. Then total kinetic energy is the addition of those two. And it climbs up until it lost its kinetic energy and it gains its potential energy mgh. So equate kinetic energy, loss of kinetic energy to gain of potential energy. That is uh, mv squared over 4 plus half mv squared equal mgh. By that you can you get gh equal 3v squared over 4. So h is 3v squared over 4g. Answer 3. Question 31. A glass of fresh orange solution contains a few orange seeds at its bottom. It was observed that the seeds just began to float at the bottom when 10 grams of sugar was dissolved in the solution. They are asking for the approximate value of the density of the orange seeds. Now, to calculate the density of the orange seeds, we know that it says after adding sugar to the solution, the seeds just start to float. So that is seeds density is approximately equal to the density of the orange solution after adding sugar. Now we find the mass of the orange solution before adding the sugar. Mass is volume into density. Volume is 500 cubic centimeters. So convert that to cubic meters. 500 into 10 to the power minus 6 multiplied by density 1000. So you get mass is 0.5 kilogram. Mass of the orange solution is 0.5 kilogram. After adding sugar, its mass become uh, 0.5 kilogram plus 10 gram, 10 grams of sugar. 10 gram convert 10 gram to kilogram, that is multiplying by 10 to the power minus 3. So 0.5 plus 10 into 10 to the power minus 3. So 0.5 plus uh, 0.01. It is 0.51 kilogram. So now the total mass is 0.51 kilogram. New density. Density is mass over volume. Mass is 0.51. Volume is assumed to be unchanged. So volume is 500 into 10 to the power minus 6 cubic meters. So you get 1020 kilogram per cubic meter. Answer is 1. Question 32. A boy sitting on a smooth turntable with a weight in his each extended hand is rotating with an angular velocity omega naught. Then he bends his hands towards his body. New angular velocity is omega 1. Moment of inertia before and after I naught and I1. They are asking the correct expression. Moment of inertia depends on the mass and the distance squared. Distance is from axis of rotation to the mass. Now, when you compare the two instances, at the first instance, the boy has stretched his hands. So then the distance from axis of rotation to the mass is more. That is, R is more, R squared is more. So I is more. I is moment of inertia is more. When you compare the two occasions, I naught is greater than I1. Then, since there is no additional torque on him, the angular momentum remains constant. That is, angular momentum is given by I omega. I omega is constant. Now, if I is more, omega is less. So, I naught is more than I1. So, omega naught is less than omega 1. And by conservation of momentum, we can write I naught omega naught is equal I1 omega 1. So the answer is 3. Question 33. A rod XY rests between two smooth boards PQ and QR as in the figure. They are asking for the position of the center of gravity of the rod. Now, when you look at the diagram, you can understand that this system is in equilibrium in a vertical plane. Here, they have not given that PQ, QR and the rod are uniform. They are not uniform. So, you can't consider that the center of gravity of each of these is at the midpoint of uh, each. So you can't take like that. So you have to think in another way. They are asking for the center of gravity of the rod. So we take the forces acting on the rod. We'll see what are the forces acting on the rod. At X, PQ is a smooth board. So the reaction force at X is perpendicular to the PQ. So you can draw a force acting perpendicular to PQ at X. So similarly at Y, QR is also a smooth board. So the reaction force at Y is also perpendicular to QR. So you can draw that force also. So, and you can see that two forces meet at a point. So we say that point is O. Now, for the equilibrium of the rod, uh, all the forces which are not parallel must go through one point. So two forces are meeting at one point at O, and the other force, which is the weight, that force also must go through O. Now you draw a perpendicular line to the to this horizontal surface. That line will go through D. So D is the center of gravity of the rod. Answer is 4. Question 34. Three objects, all having identical masses, are mounted rigidly on a horizontal surface along the y-axis by three thin rods, as in the diagram. X and y axis are located on the horizontal surface. A stream of air flows through these objects parallel to the surface and along x direction. They are asking for the magnitude of forces exerted by the objects on the mountain rods in ascending order. A stream of air flows through the objects. So when you think with the shapes and the air flow, you can understand that Bernoulli's theorem applies here. Now look at the shapes of the objects. A. The top of A is flattened and the bottom is curved. When the air flows through A, the bottom, the speed of air is more, and up, the speed of air is low. So the pressure at the bottom is low, and the pressure at the top is more. So the pressure up is more, pressure down is low. Then there will be a force downwards from high pressure to low pressure. So FA is more now. FB, downside is flattened, top is curved. So the force due to the airflow is up. So FB is small. FC, they are the shapes of the bottom and the top have no difference. So there will be no additional force due to the airflow. So the answer is FA is the greatest, FB is the smallest, and answer must be 2. But they have considered all the answers as correct answers because due to the other forces acting on these objects. When the air flows through the objects, there will be resistive forces on the object. So when you consider those forces, they are in different angles. When you consider the vertical force, uh, you can't expect the same answer as 2. So they have given all the answers are correct answers. They have given all for this. Question 35. A mass is resting on a horizontal surface and that moves up and down performing simple harmonic motion with amplitude capital A. They are asking for the maximum frequency of the motion to have the mass always in contact with the surface. For simple harmonic motion, we know that acceleration of the body, which is performing simple harmonic motion, is given by minus omega squared x. X is the displacement, omega is angular velocity, simple A is the acceleration of the body. A equal minus omega squared x. When they are asking for the maximum acceleration is there when the displacement is maximum. That is, when the displacement is its amplitude, it gets its maximum acceleration. So maximum acceleration is omega squared capital A. We can neglect the minus sign. So acceleration is equal to omega squared capital A. Now to keep this mass and the surface in contact when it's performing its motion, gravitational acceleration should be equal to the acceleration of the body which it gains with its simple harmonic motion. So simple G equal capital A omega squared. Omega squared is G over A and omega is square root of G over A. And they are asking for the frequency omega equal 2 pi f. So by substituting for omega, you can get f, so which is equal to 1 over 2 pi square root G over capital A. Answer is 4. Question 36. A whistle emitting a sound moves along the circumference of a circle at a constant angular velocity. And they are asking for the highest frequency of sound heard by a listener who is at rest outside the circle. Doppler's effect is applying here. If a source of sound is moving towards a stationary observer, the observer hears the sound with its maximum frequency. So that frequency is given by Fv over V minus V dash. F is the frequency of the sound and V is the speed of sound in air and V dash is the speed of the source of sound. So in this case, F is F naught, V is V, V dash is R omega. So you get F naught V divide by V minus R omega. Answer 1. Question 37. A ray of light is incident perpendicular to the surface AC of a right angled glass prism. And they are asking for the minimum value of the refractive index of the material of the prism uh, for the for which the ray will follow the path shown in the figure. The incident ray is perpendicular to the AC surface, so it will not refract from the AC surface. It goes straight and incident on AB. You can find the angle of incident there. Draw the normal to the surface at that point and find the angle of incidence. It is also 45. And when you look at the diagram, you can see at 45, when the angle of incidence is 45, total internal reflection takes place. It will not emerge from the AB surface. Uh, if the angle of, we assume the angle of incidence is slightly less than 45, then it may emerge to the next medium and it will travel along the AB surface. In that case, that angle of incidence is equal to the critical angle. So if you know the critical angle, then you can find the refractive index. Now, at this point, we take that critical angle is almost equal to 45, and then the refractive index n equal 1 over sine 45. 1 over sine c. C is the critical angle. So n is 1 over sine c. C is 45. 1 over sine 45. The answer is 2. Question 38. An object is placed on the principal axis of a thin convex lens of focal length f1. It forms a real image at a distance v1 and linear magnification is m1. Now this lens is replaced by another thin convex lens of focal length f2. given that F2 is smaller than F1. It is also being kept at the same position, so that means object distance is same. The new image is V2, magnification is M2. They are asking for the correct expression. For the linear magnification, you can write the expression M equal V over U. For the first lens, M1 equal V1 over U. Second one, M2 equal V2 over U. U is common, same. So, M1 equal V1 over U, M2 equal V2 over U. Now to find the answer, we want to know which image distance is more, either V1 or V2. So to find the image distance, you can draw ray diagrams to both the lenses. Draw the lens and mark the two focal points, and then keep your object beyond the focal point. To get a real image, you have to keep the object beyond the focal point. So when you draw two diagrams, you can observe that V1 is greater than V2. V1 is greater than V2. So when you compare the magnification equations, you can understand that M1 is greater than M2. Answer 4. Question number 39. 3-point charges of plus Q each are held at 3 places as shown in the diagram. A positive unit charge is placed at point A. They are asking what would be the AP distance for a zero resultant force on the charge at A. Now we check for the forces acting on the charge at A due to the other 3 charges. First we take the B charge. B and A are positive charges. So there will be a repulsive force on the charge at A. So that magnitude of the force is given by Q1, Q2 divided by 4 pi epsilon naught R square. So here Q1 is Q, Q2 is 1, divide by 4 pi epsilon naught R, distance is A. So you get Q over 4 pi epsilon naught A square. We take that force as F. So F equal Q over 4 pi epsilon naught A square. Similar force in magnitude is acting on A due to C. So that is also Q over 4 pi epsilon naught A square. These two forces are in two directions. That one force due to B, the direction of that force is along BA, along the line of BA and away from A. And the other force due to C on A is along the CA line away from A. Now we want to take the components to the AP direction and to the perpendicular direction. Then to the AP direction, we get 2F cos 30. F cos 30 plus F cos 30, 2F cos 30. And to the perpendicular direction, we have F sin 30 and F sin 30. They are in two opposite directions. So they will be cancelled off. So the remaining resultant force due to B and C is 2F cos 30. And to the resultant force at A is to be 0. Then the force due to P on A must be equal to 2F cos 30. So that is 2 into Q over 4 pi epsilon naught A squared cos 30 is equal to Q divided by 4 pi epsilon naught AP square. So with that, you can find AP. It is, the answer is 3. Question number 40. There is a circuit shown in the diagram. They are asking for the current through the 2-volt battery. For a moment, we assume that 2-volt battery is not connected there. Then the top junction and the bottom junction of the circuit has 8-volt voltage difference. Now, there are 6R and 2R are in series, and R and R are in series. 6R and 2R, 6R plus 2R is 8R. This 8 volt will be divided across 6R and 2R, giving 6 volt potential drop across 6R and 2 volt potential drop at 2R. Then after 6 volt potential drop, the right corner, the potential at the right corner will become 2 volt. And we go for the other branch, that R and R are in series. R and R, the two resistors are equal. So 8 volt will be equally divided across these resistors. So across R it is 4 volt, and across the other R it is 4 volt. So after 4 volt drop, the left side corner, the potential is 4 volt. And now look at the potential difference between the two corners of this square. 4 volt, left hand side 4 volt, right hand side 2 volt. So left hand side potential is higher than the right hand side potential. So there is a potential difference of 2 volt. 4 volt, 2 volt, potential difference is 2 volt. And that direction is to the right side. Now this moment you think that 2 volt is now connected. Due to this 2 volt, the potential difference it gives to the left side, and it is also equal to 2 volt. And before we talked about 2 volt potential difference to the right, and with this battery, with the 2 volt battery, potential difference is to the left. So right 2 volt, left 2 volt cancelled off, and there will be no current through 2 volt cell. Answer is 5. Question number 41. The diagram shows how two narrow tubes are connected to a water tank, and the pressure differences between the two ends of the tubes are given, delta P1 and delta P2. They are asking for the ratio of delta P1 to delta P2. When a liquid is flowing through a tube, the volume of liquid flow per unit time is given by AB. A is the cross-sectional area of the tube and V is the speed of the liquid. In this case, the volume which flows in the first tube is flowing out from the second tube. So the rate at which the liquid flows in both tubes are equal. And then we can write A for the two tubes, we can write A1 V1 equal A2 V2. So by that we get A1 over A2 equal V2 over V1. By using the Poissons equation, we know that the volume of liquid flow per unit time is given by delta P pi r to the power 4 8 eta L. Delta P is the pressure difference between the two ends of the tube, and R is the radius of the tube, and eta is the coefficient of viscosity. Then L is the length of the tube. Then there you can see pi, 8, eta, L, all are constants. So L is constant because both tubes have the same length. So we can ignore that and we can write the volume of liquid flowing per unit time is proportional to delta P r to the power 4. Then we know that area is pi r squared. So by that we can take r squared equal a by pi. So the previous relationship is now become AB proportional to delta P a square. So pi is also a constant. So instead of R4, R to the power 4, we wrote A to the power 2. So V is proportional to delta P A. Then we use this relationship to both tubes. Then we have V1 is proportional to delta P1 A1. V2 is proportional to delta P2 A2. We divide one by the other. Then we get V1 over V2 equal delta P1 A1 over delta P2 A2. So with that, we can find V1 equal V2 equal delta P1 over delta P2 into, before we found A1 over A2 is V2 over V1. We substitute that and we get delta P1 over delta P2 equal V1 square divided by V2 square. Answer is 3. Question number 42. A student performed an experiment to verify the Boyle's law. For that, he used a constant mass m naught of an ideal gas, and the room temperature was 27 degrees Celsius. And after the experiment, he got a graph as shown in the diagram. Then he removed some amount of gas from that volume and increase the temperature by 100 degrees Celsius and repeat the experiment again and drew a similar graph, and the gradient of that graph is also same as the previous one. And the question is to find the mass of the gas he had removed. Now look at the graph. Gradient of the graph is given by P over 1 over V, which is equal to PV. And they say in the second experiment also the graph has the same gradient. So PV, the gradient is PV. PV is constant. So in the first time, gradient is Py. Second time also, the gradient is equal, and that is PV, and PV is constant. So with the ideal gas equation, we know PV equal nRT. So PV is constant, nRT is also constant. And we can write this for both instances. N naught R T naught equal N dash R T dash. N naught is the number of moles at the beginning. T naught is that temperature. N dash is the new number of moles. T dash is the new temperature. So N naught into 300, temperature in thermodynamic Kelvin, N naught into 300 equal N dash into 400. So N naught over N1 equal 4 over 3. Then taking the molar mass is same because two instances it has the same gas. So molar mass is same by multiplying both moles in molar mass. We can find the total mass of the gas. So with that we can write m naught over m dash equal 4 over 3. So then we can find m dash is equal to 3 mo over 4. We need the difference of these two masses, that is we want the mass of gas which released from the volume. So we need mo minus m dash. So that is equal to 1 over 4 m naught. Answer is 3. Question 43. There is a circuit diagram in the picture. They are asking for the variation of voltage VAB with R dash. When you look at the circuit, you can see that one side of the resistors are earthed. So the potential at that point is 0. Now we'll take the right hand side circuit. So it is the two resistors are connected to the 6-volt battery, and these resistors are equal. So the potential drop between each R is 3 volt. So when you see from 0 to B, from the 0 potential to B, we can get the potential at B, which is equal to 3 volt. Then we look at the left hand side circuit. There two resistors are connected to the 4-volt battery, and R dash is a variable resistor. And all these graphs have the 0 origin. So we'll check what is the VAB value when R dash is 0. When R dash is 0, there will be no potential drop across R dash. So VA, potential at VA is also 0. Then VAB is VA minus VB. VA is 0, VB is 3. Then VA minus VB is minus 3. So at 0, VAB is minus 3. Then we'll go for another value. We select R dash is 3R. When R dash is 3R, it has R and 3R in series, and the 4 volt will be divided across R and 3R. So 3R plus R is 4R. This 4 volt will be divided across R and 3R. So across R, voltage drop is 1 volt. Across R dash, it is 3 volt. So start from the 0th line, and 0 to A, the potential difference is 3 volt. So at A, the potential is 3 volt. So VAB is VA minus VB, VA 3 volt, VB 3 volt, VAB is 0. So when you consider these facts, you have only 1 and 5 answers as correct. Then we go for next value of R dash. We'll take R dash is 15, because it has 12R, then 13, 14, 15. 15th is also marked there. So at 15, that is R and 15R are in series. So this 4 volt will be divided across R and 15R. 15R plus R is 16R. So for 16R, the voltage is 4, and then for 15R, it is how much? 3.7. 3.7 from 0th line to A, the potential difference is 3.7. So the potential at A is 3.7. B, it is 3. So VAB is 3.7 minus 3, it is 0.7. So out of 1 and 4, 1 and 5, we can choose 1 as the best answer. Answer 1. Question number 44. Absolute humidities of air inside 3 closed rooms and their volumes are shown in figure A. And the dew point of uh, air in room A is T naught. And the figure B shows that doors of the rooms are opened and the air is allowed to mix. They are asking which answer is correct for the common dew point of the 3 rooms to be T naught. Volume of the A room is VA and absolute humidity of air in the A room is SA. Absolute humidity of air is defined as the mass of humidity per unit volume. Mass of humidity per unit volume. Now we take the mass of the humidity in room A is MA. Then we can write MA over VA equal SA. Accordingly, for the other rooms, we can write MB over VB equal SB, MC over VC equal SC. Now, in the next instance, at B, uh, the common dew point is T naught, which is equal to the common dew point in the A room. And we can find the absolute humidity of the entire room after the doors are opened. So that is um, total mass of the humidity divided by the total volume of the rooms. That is MA plus MB plus MC divided by VA plus VB plus VC. So MA is VASA. From the above equation, we get MA equal VASA. So by substituting VASA plus VBSB plus VCSC divided by VA plus VB plus VC. And now the common dew points at B and at A in the A room is same. So the absolute humidity at A is SA. So absolute humidity at B, at the instance B is VASA plus VBSB plus VCSC divided by VA plus VB plus VC. To have the same dew point in the situation A and B, the absolute humidities must be equal. So that is SA should equal to the absolute humidity of the entire area. That is SA equal VASA plus VBSB plus VCSC divided by VA plus VB plus VC. By cross multiplying, you get SA into VA plus VB plus VC equal VASA plus VBSB plus VCSA. After solving, you get SA equal VBSB plus VCSC divided by VB plus VC. Answer is 1. Question number 45. Two capacitors are connected in series and charged by a battery. Then the energy stored in those capacitors are E1 and E2. Then they are disconnected and allowed to discharge and then charged again separately using the same battery. Then the energy stored are E3 and E4. They are asking for the correct expression given in the answers. Here you can draw a sketch of the circuit diagrams. The first instance is that two capacitors are connected in series with the battery. Second one, each capacitor is connected to the cell individually. So when you look at the diagrams, you can see the voltage across the capacitors. You can compare the voltages across the capacitors. At the second instance, you can see that the voltage across the capacitors are more than the previous one. So, by taking the equation E equal half CV squared, that is the energy stored in a capacitor, E is equal to half CV squared. When V is more, uh, the energy stored in the capacitor is more. And when the when the capacitance is more, the energy stored will be more. Now, when you compare that individual circuits, you can see that E3 is greater than E4. And when you uh, look at the first diagram, that is the capacitors are in series, the voltage is less. So the E1 and E2 are lesser than E3 and E4. And also, again, take the equation for the energy stored in the capacitors, E equal half CV squared. When C is more, energy is more. So E1 is greater than E2, but they both E1 and E2 are lesser than E3 and E4. So when you look at the answers, you can select the answer 5. Question number 46. A rectangular heavy metal block of mass M is shown in figure A. The dimensions of the metal block is given, and then the 4 blocks identical to that mentioned block are stacked together as shown in figure B. They are asking for the overall height of the 4 blocks. The blocks have been placed one over the other. We mark the top block as 1, second one 2, third one 3, fourth one 4. So top one is 1, last one is 4. Now when you consider the second block, you can see that mg force acting on the second block. When you go for the third block, 2 mg force will be acting on it. The last block, there will be a 3 mg force on it. So due to these forces, there will be a contraction of these blocks. So we want to find the contraction. To find the new height, we want to find the contraction of each block. Now, for that, we need the Young modulus equation. Young modulus is stress over strain. Stress is force over area. Strain is extension or the contraction over the original length. So, by that, we can get the contraction is equal to FL over AY. F is the force, L length, A cross-sectional area, Y Young's modulus. And when you think of the second block, we say the contraction of the second block is E1. So E1 is MGL over AY. Then third block, the contraction is E2. The force acting on it is 2 mg. So E2 equal 2 mgl over AY. Last block, force is 3 mg. E3 equal 3 mgl over AY. The total contraction, E1 plus E2 plus E3, which is equal to 6 mgl divided by AY. So the original length would be 4L. Now the new length is 4L minus contraction. So 4L minus 6 mgl over AY. Answer is 4. Question number 47. Two blocks are placed in contact on a smooth surface as in the figure. If an external force F is applied on the block of mass 2m, they are asking which figure shows the forces acting on the two blocks correctly. When you look at the answers, you can see all the vertical forces are same in each answer. So don't worry about the vertical forces. Let's go for the horizontal forces. Now, F force is applied on 2m. So due to that force, this system will have a acceleration. We say the acceleration is simple A. And when you take these masses individually, each mass gives a contact force on the other. So 2m will give a force on m to right. And by m, there will be a force on 2m to the left. So we take this system as a collection. And use F equal ma to the system. Then F, the given F equal, m is total mass 3m, acceleration A. From that we can find A, acceleration is F over 3m. Now take individual boxes. We take the box m and use F equal ma again. We suppose that the force on m by 2m is F dash. Similarly, there will be F dash force on 2m by m. So now for the moment, we think that force on m is F dash and the direction is to the right. F dash equal ma. F dash equal ma. So acceleration we found before. Then you get F dash is F over 3. Then the answer is 2. Question number 48. A rectangular wire loop ABCD is inserted perpendicular to a uniform magnetic field as shown in the figure. This loop is taken from position 1 to position 3 with a constant velocity. They are asking for the incorrect statement. Answer 1. When the loop passes through position 1, a constant EMF will be induced only across section BC of the wire loop. Now, if a conductor is traveling across a magnetic field, cutting the magnetic field lines, an EMF will be induced across the conductor. So, here BC is traveling across the magnetic field, cutting the magnetic field lines. So there will be an induced EMF across BC. So that is right. Answer 1 is right. 2. As the loop passes through position 2, constant EMFs will be induced across AD and BC and they are equal and opposite to each other. Now, when at the position 2, there will be a magnetic, so there will be a induced EMF across BC and across AD, similar to the position 1. Now we want to see the direction of this induced EMF. To find the direction of the induced EMF, you have to use Fleming's right-hand rule. So keeping the three fingers perpendicular to each other, the thumb shows the direction of the motion of the conductor and the second finger to the direction of the magnetic field, and third finger, that is the middle finger, shows the direction of the induced EMF. Now at BC, your thumb to the left and the second finger inside the book, and the middle finger is from C to B. So that is induced EMF is from C to B. At AD, it is similar to BC. The direction of motion left, magnetic field inside the book, and induced EMF is from D to A. So the induced EMF are from D to A and from C to B. So when they going through the loop, they both go in opposite directions. So second answer is also right. Then 3. At position 3, a constant EMF will be induced only across AD. That is also true. It is similar to the position 1. That is true. 4. At position 2, the resultant force on the loop due to magnetic field is 0. Now you know the total EMF across the loop is 0. So there will be no resultant force on the loop. So fourth one is also right. Fifth one, the direction of the forces due to magnetic field on the loop at position 1 and 3 are opposite to each direction. To find the direction of the force, you have to use Fleming's left hand rule. So from the first 3 fingers, you can point the thumb to the direction of the force, and second finger to the direction of the magnetic field, and middle finger to the direction of the current. So when you place fingers properly to find the direction of force on AD, you can see it is to the left. On BC, it is to the left. So they are not opposite, they are to the same side. So 5 is wrong. The answer is 5. Question number 49. 3 thin, long and straight wires carrying equal currents are held in fixed positions perpendicular to the plane of the paper as in the figure. And another 2 thin, long and straight wires are also held perpendicular to the plane of the paper at points x0 and y0. And they are asking for the currents x0 and y0 to produce a resultant magnetic field at the point O, mu naught I over 2 pi. To answer this question, you should know the direction of the magnetic field produced by each wires. To find the magnetic direction of the magnetic field, you can use the right hand grip rule. There, you keep your 4 fingers together perpendicular to the thumb, and the thumb will give the direction of the current, and the other 4 fingers will pointing to the direction of the magnetic field. Here we are going to find the direction of the magnetic field produced by A first. Now when you look at the point A, you can see across there, it shows that the current is inside the book. So you have to point your thumb inside the book, and you can see other 4 fingers are turning clockwise. So when you turn your 4 fingers clockwise, you can find your 4 fingers are pointing to the minus y direction at O. So the magnetic field produced by A is downward, is to the minus y direction at O. So you can mark that magnetic field as BA. It is to the minus y direction at O. the magnetic field is BA to the minus y direction. And when you take B and C points, you can see the current is towards the book. So point your thumb towards the book. Then you can find the direction of the magnetic field at O is towards plus x. So you can mark uh, that magnetic field due to B as BB, it is towards the plus x direction. And the magnetic field at O due to C is is BC is also to plus x direction. So plus x direction has two magnetic fields, BB and BC. Minus y direction, there is only one magnetic field, that is BA. Now the question says that the resultant magnetic field at O is to the positive y direction. But we noticed that there are two magnetic fields to the x direction. So that must be cancelled off by a magnetic field to the minus x direction. We'll check which wire can produce a magnetic field in the x direction. B and C produce magnetic fields in the plus x direction. So the wire at y naught can produce a magnetic field in the minus x direction. So for that you have to choose the direction of the current in the wire y naught. If the direction of the current in the wire at y naught is inside your book, it can produce a magnetic field to the minus x direction at O. So the magnetic field in the minus x direction and magnetic field in the plus x direction is opposite, and if they are equal in magnitudes, they will be cancelled off. Anyhow, the current in the wire at y naught must be inside the book. When you look at the answers, you can choose only 1 and 3 which satisfy that condition. That is, the current at y naught is inside the book. So it shows only in 1 and 3. There is only one magnetic field to the minus y direction. But the resultant magnetic field at O should be to the plus y direction. So the wire at x naught must give a bigger magnetic field to the plus y direction. To give a magnetic field to the plus y direction, the current in the wire at x naught should be inside the book. So the current in the wire at x naught is inside the book, and the current at y naught, current in the wire at y naught inside the book. So when you look at the answers, you can select answer 3. Even without going for the magnitudes, only by checking the direction of the current, you can choose the answer 3. Question 50. A particle is attached to one end of a light elastic string and the other end of the string is fixed onto a vertical frictionless wall at y equals 0 as shown in the figure. The particle is then projected vertically downwards from the position y is 0 with a velocity v naught. And they are asking for the y coordinate of the position of the particle at which the particle comes back to rest again. What will happen here when the object is projected downward? It will fall under gravity to a height of L naught and then stretches further down due to the elasticity of the string until its velocity is 0. So there is an elastic force generated in the string. So the object will be pulled back and it tends to move up again. For a moment, we will assume that the object is released from rest. So that is initial velocity 0. So it will fall down to a height of L naught under gravity, and then it stretches further down until its velocity becomes 0. Then due to the elastic force generated in the string, it will be pulled back and it will move up again. Since the initial velocity is 0, the object which is moving up will momentarily stop again at that point. Actually, it is not released from rest. It is projected with the velocity v naught. So now it has an additional kinetic energy. So with that kinetic energy, it will actually it will not stop at the initial position. It will move up. So it will move up to a further L naught plus the extension distance. If the extension is x, the total height from y equals 0 is L naught plus x. So using the conservation of energy, we can write half mv naught squared equal mg L plus x. So with that, you can find L plus x, which is equal to v naught squared over 2g. The answer is 5.